You definitely need to get in there.
We're in aisle 18.
Oh, 17.
Optimize and personalize the assortment so they can customize and accelerate.
Careful.
I'm good. I know. Well, not till 2.
Are you lining up for VR? I don't know.
Should ask if it's still on.
Yeah, true that. Hi, I'm just wondering if that talk on exoskeletons is still happening.
What time did they say it was happening?
12:30.
These two ladies right here,
Yeah.
right? They might have a better answer because I don't. They should be doing it.
Okay.
Right? So just like these two ladies right here, were they able to help you at all?
I'll go over and have
Okay,
a chat.
because he's
Thanks.
normally here.
Yeah. Okay, cool.
Red, green, green, yellow.
Unfortunately, I can't grab that. Let me reset. We're gonna fix it. Oh, you're done? What do you think?
We're at the wrong state. It's over there.
Oh, it's over there, is it? Oh. Okay. Yeah, the guy said, yeah, he's usually here. It should be happening. Oh, you can have the rest of this book.
Orion, and you build it similarly to
like Legos. So you have a habitat where the astronauts live. Actually, it is a collaboration with international partners. So we have an international habitat as well that they're going to be developing. And then we have a module that you see at the bottom, you see a cargo logistics module, and at the top you see an extravehicular activity, I guess a room where you can depressurize and get the astronauts into their spacesuits so they can go outside. So you have a really complex and at the same thing simple system that would allow us to access the surface of the moon. We can connect and dock a lunar lander to that gateway and go down and explore the moon. And there we are on the surface of the moon. And this is the view that we're going to have when we go to the moon. It's going to be an exciting time. We have a lot of work to do. We have to find that water, understand where it is, understand how to work it so that we can we take water and we can break it up and use it for oxygen. Not only for drinking, but water is needed to grow plants. If we want to say when we want to go to not only to Mars, but stay longer on the moon, we have to learn how to harvest those plants, grow those plants. You see what happens, you watch The Martian, right? So you see how delicate ecosystem that is. And finally, you also use water to create propellant because you split it and you get hydrogen and oxygen. And then you have all the elements for going back and forth. And one of the things that is very relevant in tying it to exoskeleton is that we have spacesuits.
Yeah, and actually,
right.
I'll jump in there. So, if I'm not mistaken, so all these, you use the term delicate quite a lot in terms of describing all these, the intricate actions and activities that are being done out in space, whether it's extravehicular activities or even on the lunar surface. And so these actions require fine motor control, working on objects, and while to a certain extent some of the challenges there can be mitigated by designing things to be accessible with these large gloved hands, the reality is it should put a lot of burden on the user, right? Because isn't it? And so actually, and this will actually defer to your wisdom here. It's particularly difficult to actually manipulate and move in that spacesuit.
Yes. So if you look at that spacesuit, it is not only heavy but bulky. A spacesuit with a pack, it's about 300 pounds on Earth. So when astronauts go to the Neutral Buoyancy Lab to practice their missions, there's a crane that grabs the astronaut and puts it in the Neutral Buoyancy Lab. It's pretty heavy. They cannot maneuver and move around with the spacesuit. On the moon, we have a gravity that's about 1/8 of the Earth. So you have other challenges. You probably lose your balance. It's not an easy thing to work with. And on top of that, these things are pressurized. So it's like fighting a rubber band. It's like having a constant workout. So the natural state of a spacesuit is to be open.
So along these lines?
Open like this, and the astronaut has to fight it. So it's almost like you have a rubber band, and the same with your gloves. So dexterity, and if you've seen a spacesuit, they're not form-fitting. It is quite bulky, and the reason being is because those spacesuits have lots of layers that you have to be protected from radiation, you have to be protected from the thermal extremes. So helping with that would go a long way.
We could actually use exoskeleton technology for exactly that kind of situation to help with that. So with exoskeletons, there are rigid exoskeletons, which is like the Onyx here, where it is a rigid frame and the actuation is mounted onto the structure, providing force into the user. But you can also have soft exoskeletons. Now, soft exoskeletons, by comparison, have a lot less rigid components, but actually rely on the cable-driven system, where you can have a fabrics or textiles with mounting points hooked up to those cables, so that you're actually more moving the person directly, not so much pushing on them using that frame. And so one of the things that we envision here in a future spacesuit is that you could actually weave a soft exoskeleton into that spacesuit, so that you can have, rather than the user, rather than the astronaut putting all that effort into moving the frame and fighting that balloon, as it were, the exoskeleton inside of that spacesuit would hold the position that the user moves it in. So the astronaut, instead of having to worry about holding the tool and working with that tool with that fine motor control, they just need to worry about putting it in that spot and just managing the difference between the forces, so that it takes all that burden off their hands, off their joints, off their body. So again, coming back to, takes the burden off their body, making it easier to do their job, so they can focus on the task at hand, not about just holding themselves in that position.
They're not thinking about the fatigue.
Exactly.
So they can concentrate.
Exactly, because it wouldn't be nearly as much fatigue at that point.
Right.
So,
It
yeah.
may be a task that would take you 8 hours, now it takes you 2-4 hours. It
Yeah.
just allows the astronauts probably to explore more, to go further in their mission, rather than spending their energy in just fighting the suit.
Yeah.
So that's the moon.
Yes.
That's true.
What comes next?
What comes next?
Mars. Pretty excited about Mars.
So this is the gateway for Mars, right?
That
Or that's
is-
the concept.
That's the concept of our Mars Space Camp. So Lockheed Martin has a concept that extrapolates from the gateway around the moon to Mars. And it's just like I mentioned before, just like Legos, it is Orion based, because Orion is already designed for deep space. So Orion can go to the moon and can go to Mars. And all of the key elements that would make up such a Mars base camp are technologies that we already have. There's a few kinks that you have to always iron and think about. So there's a few tests and qualifications that need to be done. But the point is that it's not science fiction. This science is not fiction. Is that how you saw it?
I think that's exactly how you
I
put
think
it.
there's a logo about that.
Yeah, there's a logo about, yeah, not endorsing, but I think it's pretty cool. Yeah, this science is not fiction. We have all the elements now to go to Mars. And so that's something that we are working on. And that similarly is going to serve as our staging area to be able to go down and explore the surface of Mars.
So is that part of the commercialization that you were talking about earlier, like the new economy that might be?
Yes, so Orion commercialization. So it starts with the moon actually.
Yeah, okay.
So Lockheed Martin, and I've been talking about this, we've been both talking about this at our booth, is it's a new era. So where before everybody was working with the government, and the government had to use their budget to subsidize going to space in every shape or form. Now NASA is opening it up to public-private partnerships, and what this means is that anyone that wants to fly in space, whether you want to fly a product, an experiment, whether you want to do outreach, you want to do TV from space, you name it.
Music.
Music.
Yeah.
Yeah, musician.
So space people can hear you play?
Oh, okay.
Okay.
It's
So-
a pressurized compartment, yes.
So, but you're looking for folks to fly on Orion, right?
So right now we are looking at your ideas of flying in Orion. So if you have any idea, you go to the Lockheed Martin website, lockheedmartin.com/flyorion, and you can give your ideas as to how you want to, what you want to fly in space, how you want to fly it, and we brainstorm together. So it's pretty exciting, and so going from there in the future, just envision having your logo, like in the movies, outside your spacecraft, or just simply being able to be a part of that exploration. You no longer have to be a spectator. You can be in the front seat, flying whatever your idea is. And so, going from that base camp around Mars, you can get down to the surface, and when you go to Mars, it's completely different. It's the gravity environment is different than the Moon.
Right.
It's about 40% of the Earth. So whereas before you had the issue of
So we were a little, we could bounce.
You could bounce.
Yeah, but now you get to Mars and we're not bouncing anymore.
you could leap, and
Yeah.
now on Mars you have not only a different gravitational environment, but you have steeper canyons, bigger mountains, and terrain that we are still learning from. So you have different challenges. the spacesuit is heavier in Mars, and it cannot be built the same way. So we have different challenges that we have to work on. We have also the same sustainability issues. We have to find water, which we know there's water there, but then you find water and you have to process the water. So it's not just about finding the water. It can be polluted with other contaminants. It can be mixed with other chemicals. So it's not a simple thing. So it takes time. And this time we're not going alone. We're gonna have rovers and humans and robots working together.
I'm sorry, so I just have to say this. Every time I see this picture,
Right. I was going to say, look at the picture. What's missing, kind of,
Well,
when it comes to the
No,
load
no,
transfer
it's
thing?
definitely
well, you know,
different.
so it's a person and their rover, which is a dog's name. It's their pet rover. I'm sorry.
Yes.
All right.
Yeah, you see that.
This is why they leave me in the lab, guys.
Yeah.
It is how it's fine zones, but so similarly, we envision that your exoskeleton
Yes.
could help you.
So can you talk about the load transfer part?
Yeah,
Because I
so-
see it that is a bulky pack,
So-
if
Yeah.
ever I've seen one.
So to what Vanessa was saying earlier, these spacesuits are weighing now in the 300 pound. These weigh in the 300 pound range. And so with Martian gravity, that becomes maybe 150 pounds and change. And so as someone who's actually worn 150 pounds and had to move around in it while trying on exoskeletons and trying on suits, that is already, or even without the exoskeleton, that is already a very difficult weight to manage, very difficult weight to carry. So this is where we come back to actually more of the rigid exoskeleton structure. Now, we use a technique called passive load transfer, where we take the weight of something mounted on the person's body and transfer it through the frame, through the structure to the ground around the person, so that they themselves are not in that load path. And so this is the kind of solution that we envision using in a spacesuit here that's now weighing upwards of 150 pounds. That weight will be built onto the frame, the user being inside of it, and then we can use our sophisticated controls and architecture and actuation to help the person not only carry that weight in that environment, but now we can use similar technology to what's happening here on the Onyx to help them traverse those steep hills and inclines, so that they have now, again, more energy to go explore that surface of Mars. And so this once again is a critical application for exoskeletons in the future, because it's all about helping them do their job better and with more energy. So yeah.
Perfect. So there would be more of a framework on this photo, right? Where there's something that actually connects to the ground.
Yeah. And
Is
so in this, the way this kind of image would change. So right now it's more of a soft shell that you see as the spacesuit, but that would start having more rigid elements built into it to provide that load path to the ground.
So would you also kind of put communication and other things on this exoskeleton? I mean,
so one of the things that we see with exoskeletons that ends up opening up the aperture for is the exoskeletons as a platform. So now that you have a structure and now that you have sufficient battery power to drive an exoskeleton, you could tap off from that power source to now drive other equipment that you normally couldn't necessarily carry because there's too much weight on the person, or you're adding too many batteries. Because the suit can also hold its own batteries now. So you can facilitate communication equipment, any other kind of scientific equipment, things that need to be carried, using that exoskeleton as the hub of that platform, everything else building out from there.
interesting. And then I just kind of wanted to make sure everybody notices Gavin is sitting down in an exoskeleton.
Yeah, so
I think you should kind of talk about that when it comes to the form, fit, and function of some of these things, because when you're in a spacecraft heading that way, bulky exoskeletons are not going to do the trick, right?
And so 2 years ago, I was actually here at South by Southwest with another one of Lockheed Martin's exoskeletons, the Fortis, which was more of a standoff from the body kind of frame for holding heavy tools. This year, I'm here in the Onyx, which is actually a different philosophical design architecture, where it's now more of a conformal design that's intended to not be visually standing out, because you want it to be form-fitting to the body. Because when it starts applying power and when the actuators start applying power to the person's body, you want to direct transmission as fast as you can. So it's a semi-rigid frame where I have rigid shell here at my shins, at my lower thigh, and at my upper thigh, coupled with a bunch of Velcro fabric harnessing, so that I am tightly coupled to the frame, so that as I move, it moves with me, and vice versa. And so these are the kind of things that we see with exoskeletons moving forward, is this kind of tightly coupled design, and that's a similar kind of structure that would most likely be used in this kind of configurations.
So that's kind of that transparency thing you were talking about.
Yep.
If you can't, I mean, if you realize that it's in your way, then it's not doing its job correctly.
Exactly.
For example, we would go to lunch and nobody noticed.
Yeah.
Right? I think that's what I mean, that's what we were kind of experiencing around here is.
And which is kind of the goal. You're not really trying to draw attention to it. You're just giving yourself that boost of power. And I'm not walking around with a giant Sawzall. It's just here to help me move, and that's the whole purpose of it.
So let's see what we have. Okay, so as we start to wrap this up, because I want to make sure we leave enough time for questions and things like that. Any final thoughts on the whole idea of space exploration, exoskeletons? I mean, what's kind of the next step? We just need to start kind of thinking more about it and things like that when it comes to the space side.
I think it's a really exciting time, and what I keep coming back to is that space doesn't belong only to rocket scientists anymore. You don't have to feel that you don't play a role in it. We have to become a multi-planetary species for us to move forward. And so it's going to take each and every one of you, each specialty that there is, because it's, whether here on Earth or in space, it's always about communities working together. It's as much as a scientific experiment as it is a sociological and psychological endeavor. So I am excited to engage you and to give you the good news that there will be a role for you moving forward, and we just need you to come along and get on board with the idea that you can, because it's very exciting. The next steps are going to be coming. They're going to be very obvious. I think NASA is reaching out more and more. Lockheed Martin as a space company has traditionally been known as a company that works for the military, when in reality we have done lots and lots of things, and
in the commercial space, right?
In a commercial space, and I love that it's going from a company that is traditionally viewed as serious and military to actually us communicating a little bit more. It's been a transition from when it started to actually sharing all the cool work that we do in many areas. It's just not just the military. We should toot our horn a lot more in terms of what we do with space, because that's the exciting stuff. That's the stuff that dreams are made of. And there's a lot of passionate people working in these areas. So it's going to be an exciting time.
Okay, Gavin, so any final thoughts as we start to close out South by? I mean, you've been walking around. So how long have you been in the exoskeleton?
All right.
And this is part of testing too, right?
It's
So,
a red
Like,
light, right?
you've been with this thing 5 days, man.
Yeah. So we've done these kinds of gone out to these conventions and events in South by Southwest. And one of the things I like about these opportunities, not only to share this great technology and talk about it, but actually from just a pure engineer and science perspective, I consider these opportunities for endurance tests. So I've been wearing, over the course of the now 4th day that we've been here, I've put a total of 26 hours in the Onyx, wearing most of that just been consecutive for 10 hours a day, 8 hours a day. And so as a result of which, I use that as an opportunity to say, hey, this part's feeling a little different, or what do I do about this? And I'm emailing back home with my team of engineers saying, hey guys, these are the things we need to keep track of. Like, oh, hey, I didn't realize I was doing that thing. Then they say, no, Gavin, you're not tightening the harness enough. Like, oh, okay. So this is part of the dialogue about this technology that's so fascinating and exciting, because it is a new technology, and it's a new technology that I'm always excited to share, because it's something that helps people. It is we work with universities to back our claims up with numbers that it reduces energy exertion, it makes people more comfortable, they can do their job better because they're not getting tired, and it's something that I know helps people. And actually, from just as a side note, from a personal note, like, my brother's a Marine, my little sister uses a wheelchair, and my daughter is in a firefighter academy. So like, everyone in my life can benefit from this tech. So yeah, like, being able to work on this technology is a big deal for me, and so getting it to share it with people is nice. And so I'm glad I was here. I'm glad I had a chance to talk about it with you, everyone here. And so yeah, I think I answered the question.
Yeah. So I just have one more. So there's another little girl. She's staring up at the stars right now. So, you know, what can she do? Because you know there's somebody right there, and they're looking up to you because you both have dream jobs. I don't know if you know it or not.
Absolutely.
Because there's somewhere out there, there's a little girl thinking about what she could do. What advice could you give to somebody like that? How could she get started?
I'm gonna go there.
Yeah, I'm gonna go there, man. Sorry.
I would tell her, what can't you do, right? And why not you? There's nothing holding you back, and you have the technology, and you have, this is the right time. That's all I have to say. It's the right time. Don't give up. Keep following your dreams.
Yeah, same question. There's somebody out there, they're either doing animation or they just love robots. Aren't you a judge for First Robotics?
I am, yeah. So I was a mentor for a number of years, and so actually, when I get back Thursday, I'll be going straight to the judge dinner and then start judging for the rest next weekend about kids working on robots. It's like, this is an incredible field, and so when I'm giving demonstrations, when they bring like high school kids and college kids, but mostly high school and elementary school kids through our facility at Lockheed Martin, one of the things I always tell them is that this is a young science. This is a new technology, and if they're interested in working in this kind of field, by the time they get to high school or college or even grad school, like, we're still going to be working on new solutions. The technology I have today is the beginning of what is so much to come, and we know a lot of what's out there, but there's still plenty more we don't. And so to them, I would say, don't stop. There's more to do, and there's lots of fun to have with it. And we're exoskeletons.
Fair enough. Fair enough. So we'd like to offer you guys a chance to ask some questions. We have a microphone. Go ahead. Absolutely.
Thanks for the great talk. Gavin, you said something that was around my interest right at the end about you have a family member in a wheelchair. My interest is broader, but in the same, you know, what's being done in kind of the healthcare, whether it's physical therapy or whether it's for elderly. I have an 88-year-old dad who keeps falling down, and I keep thinking about how this technology could be used either to train balance or to somehow augment and to maybe, you know, get more people, either keep them out of wheelchairs longer or get them out. So can you talk a little bit about that?
Certainly. So exoskeletons can dominantly be classified into two forms: medical exoskeletons and non-medical exoskeletons. Medical exoskeletons are dominantly focused on restoring a natural mobility, which is a scenario you've just described. Lockheed's work predominantly focuses on the non-medical exoskeletons, which is about enhancing a natural mobility. That being said, there's actually a significant amount of work and a number of companies out there who are working in the medical space, covering a whole host of the scenarios, most of which you just listed as well. But one of the really exciting things about what we do is that we have industry design partners on exoskeletons who are actually focused on the medical variety. So as Lockheed Martin comes up with innovations in exoskeleton technology, we have the ability to feed it back and support the overall growth of exoskeletons as a whole. But there are actual important nuanced differences between the medical and non-medical. One of the more significant ones is what happens when the suit loses power. So in a medical exoskeleton, if the power shuts down, I'm getting there. So if a medical exoskeleton, if the power shuts down, that person is relying on that exoskeleton to stand. So it needs to maintain that structural rigidity to keep them up. However, in the case of Onyx, a non-medical system, if I shut it down, I can still move. I have to be able to continue moving, because if I'm that firefighter at the top of the building and my suit shuts down for some reason, I still need to be able to get out of there. And so it's a nuanced difference, but it's an important difference. And so there are many more beyond that, but that's where the differences start coming in for medical and non-medical. But I am glad that we get to at least contribute to that side of the field as well.
What's your question?
Are there any cases of your exoskeletons being used in a military setting?
Yeah. So Lockheed Martin is currently working with the U.S. Army in advancing this specific exoskeleton for getting it ready for soldiers and engagement along those lines. But one of the other really exciting things about this technology is that it's really useful for pretty much anyone who has knee-intensive activities. An exoskeleton is a tool for a job. It's not necessarily a military product or an industrial or first responder. Just in the same way that there's no reason for you to swing around a hammer all day long if there's no nails. It's all about taking tasks that are already overtaxing for the body and bringing it back to a manageable level, whether that is first responder, military, or industrial, or anyone along those lines. So, short answer, yes, but there are all hosts of industries that can take benefit from this kind of technology.
Yes, sir.
Yes, can you give us any insight into how you're designing for extended solar radiation exposure, both on the lunar surface and on the Martian surface?
So let me see if I heard you correctly. Can you give me insight into how we're designing for extended solar radiation? Wow. So there's lots of things that are being done, and it depends on where you are. So currently on the space station, we have just a small portion of space station where the astronauts are protected. So if we have a solar event, the astronauts need to absolutely be there within a couple of minutes, because I think it takes 4 minutes for the radiation to get there. With the gateway, scientists and engineers are already working on ways so that the whole vehicle is designed. There, always with radiation, the problem is it's heavy. We know how to protect from radiation. It's just pretty heavy. We cannot fly lead up to space because it would be pretty expensive, not a possible proposition. But there's a lot of polymers that have been developed since we first started caring about radiation, since we went to the Apollo. So there's polymers that are being embedded within the structure. With the spacesuit as well, there are vests that are being developed. I know that we have an experiment that is flying up in ISS in July, where it's a vest that is made of special polymeric material where it covers the main organs. So in science, there's something as low as reasonably allowable. So ILARA, I think is the acronym. And basically you cover there's a few organs that are critical, and that if you protect those and you keep them to the lowest levels, you know that a person will survive. So we're flying that vest and trying it out so that maybe we can incorporate those materials more seamlessly into spacesuits. And so we can extend a mission from, say, 30 days to 90 days, so that the astronauts can just have a better chance of having a longer career in space too, right? And similarly with Mars. And the moon, and so looking at the moon and Mars, how we would, say, live in the moon, we don't have an atmosphere. So very likely the moon, rather than seeing structures above the surface, we would just do structures underneath the surface. We'd exploit caves that we have from early volcanic activity that the moon had. So the moon has a lot of cavernous, I guess, structures underneath the surface, and that is a perfect environment. So the idea that we would have structures above the surface, it's probably just for infrastructure like power and water, reutilization, but everything else would be subterraneous. Whereas in Mars, we have an atmosphere. It's not like the Earth, but we'd be able to have protection from radiation, and we could have infrastructure above the surface that would double as protection from radiation.
What about the magnetic field on Mars?
So we're gonna take the next question real quick.
My name is Stephen Ellis. I work with a hardware, robotics, and AI research lab out of Dallas. And I wanted to ask you about
Thank you.
The computer that's on the exoskeleton. Did you guys custom design most of that, or did you work like NVIDIA for a partnership or something?
It is a custom design along with the artificial intelligence that was designed to go along with it.
Yeah. So we're partnered with a Canadian company called Botemia.
Yes.
And that's part of our partnership. So, yeah. Yes, sir.
My question kind of piggybacks on that.
Sure.
The way the skeleton is reacting to you is based on your movement, I assume, right?
Right.
What is the future? I mean, beyond that,
Oh, man.
you can't move. How are you going to start controlling
Well, we
that?
had dancing, ballet.
Okay. So I will just pretend someone asked the follow-on question to this one, and it comes down to so synchronization is part of this. Is a big part of this when it comes to exoskeletons, and really capturing user intent. So the way Onyx works is that it uses the suite of sensors, where it's IMUs, encoders, accelerometers, all of these, to determine what my body geometry is as I'm moving. And so once it knows how my body is moving, it can predict the next step. But the reality is I have to move first. So if you look at the when you can actually capture someone's intent, at time 0, the primary motor cortex says, I want to move. about 75 milliseconds later, you have muscle cells that are firing off that are basically recruiting the forces to perform a movement. And then about another quarter of a second later, you've now recruited enough cells and then moved enough that an exoskeleton like Onyx here can determine what you're doing and then predicting. So this is what's called a kinematic control architecture. And it's a mechanomyographic, so it's reading the mechanical forces of your muscles to determine what your intent is. If you want to pull that back to that 75 millisecond mark, now you're using a technique called electromyography, where you read the voltages generated by the muscles to determine the intent of a user. And so that electrical signal that's generated by your muscles is actually with a little bit of signal processing, you can actually determine the amount of torque that's about to be generated about your joint by those same muscles. So all of a sudden you have a system that is both reactive but still faster than you. And so that's what we believe the next generation is. And so Lockheed Martin actively engaged with the university to research these kinds of control architectures. Now ultimately it'd be great if we could put a little crown on and say, hey, we can read the brain, which is, once you get to that point, there's really no further back you can go in the timeline to figure out what someone wants. And there are some amazing university professors working on that specific technology. But one of the biggest challenges there is motion artifacting, as well as just the overall resolution of sensing at that level. So the most near-term, next-generation controls is absolutely reading the muscles themselves directly.
Yes, sir.
Well, I think you just answered my question.
I'm all for efficiency.
I was going to ask, what do you think is the limiting technology, or what breakthroughs in technology do you need to advance the next generation? Which sounds like sensors.
So, robustness of sensors are a big deal. So we're getting, robustness of sensors is a big deal, especially if you're moving to like a muscle sensing kind of activity. Power is honestly still a big challenge. So I'm pretty pleased with how Onyx has performed. In that so Onyx, and it was on the original, it was on that first slide, but Onyx has 8 hours of battery life, which is really a floor, not a ceiling. But it's 8 hours of constant heavy use. By comparison, I've been in the suit for 26 hours, and I haven't even hit half drainage. I haven't even drained my power halfway so far, because I've just been milling around and not actually using the suit for intense lifting.
What battery technology are you using?
So it's a standard rechargeable military battery, really robust, really reliable, really rugged. Don't want to get into those specific considerations, I do apologize. But it's a commercially available source. And so, because that's a big deal of this technology. So, but yeah, so those are some of the limiting factors of the technology there.
What about the gloves?
What about the gloves?
Cool factor.
Yeah. So the gentleman asks, what about the gloves? And so there's a showmanship aspect here where I help guide the eyes of the audience. Is a big part of it. Also, it actually matches my outfit. So. White gloves would have made no sense. I'm not a magician.
That's a very scientific explanation.
It's very scientific.
Yeah, that's true.
Do you have another question?
Yes.
Sorry, one last question.
Sure.
Just wanted to ask about can you elaborate on any research projects being done on brain-computer interfaces being used with exoskeletons?
I don't know.
I mean, I know of a couple. So one of the universities that we work with is University of Florida, Dr. Daniel Ferris, who, among many other research topics that he's done, is on electroencephalography. And so he's one of the more prominent figures in this field. And there are a number of other universities that we've worked with, but he would be one of the first people I would look up on in terms of information on that front.
Awesome. So
also, he's an awesome guy.
Oh yeah, he's a great guy. Any other questions before we close out? Okay, so again, we've got some flyers in the back. If you're interested in the Orion, go ahead and tell us one more time about, I can put what? Like, I can submit an idea? Is that what this is?
You can submit ideas. You
submit
can submit
ideas
online. There's a flyer back there that tells you how to brainstorm with a fellow geek at Lockheed. Yes.
Okay. And then First Robotics, you're judging...
Yeah, I'm judging First Robotics.
Where you're leaving, and then you're judging when? Tomorrow?
The process starts tomorrow.
The process starts tomorrow.
But until then, I'm in the suit for a little bit more if you guys want to talk and ask some questions.
So we're going to be here just hanging out with everybody, but we really appreciate you guys coming.
Thank you very much.
Thank you so much.